I have seen some hands going up, so I will hand it directly to the audience. Please.
Thank you. These are really exciting technologies that have hit some pain points for myself that I'm really interested in. I was just wondering if you could expand a little bit more on a few things. I'm a big user of MDNS, Avahi. I use it for services on my local network. And I also, when I have nested repositories, I'm a big fan of using relative URLs in my Git modules file, because I think that a bit of a weakness in Git is just being tied to a specific server. It would be cool if there was like a URN or URI or something like that. So that's another cool thing. So I just wanted to know your thoughts on that. Maybe if you could expand a little bit on, it sounds like you can use, if you wanted to, you could use MDNS or constrain what protocols you could use for your remotes, and how that could be implemented. That's all. Also, if any of you have heard of NNCP, and if that fits in.
There's a lot in this question. I think as for MDNS is just an announcement to the local network, I guess. I think if you would want to use this for Git remotes, you'd have to have something that listens to this. Usually Git is not in a daemon mode, so I guess you would run into some problems. I'm not sure. Yeah, if you have a local forge running, you probably can use MDNS to discover remotes.
I can say something. I didn't mention it so prominently, but I also mentioned MDNS for this very reason. I think we're going a bit of a different route than IRO it's doing currently. I'm not also entirely sure because I didn't dig into it very deeply, but for Radical, what we're trying to do currently would be to hook into, for example, Avahi. So if you run Avahi locally, you can ICP to Avahi and tell it, look, I want to announce a service. You can do the same for other implementations. You can do that for Bonjour. You can do that for systemd, what's it called, resolved. And also, I think there are also Windows APIs for this. Then, of course, you can also do the UDP yourself. Yes. And with Radical, what we would be announcing would be basically there is a Radical node. The public key of the Radical node is this, and the address comes directly with MDNS. And then your local Radical node would start a connection and peer with this other node, like any other node on the internet, basically. Yeah, so then, yes, I have to say we're not so flexible and we cannot cover any remote. We can only cover Radical currently. Yeah, but we definitely want to enable this use case and we're working on this. And no, I do not know NFCP. Yeah.
Since Lorenz has questions, then I'll go through Lorenz's questions. The problem with distributed is mental capacity of humans to map the space, right? So that's where GitHub is helpful already, so they know, oh, it's on GitHub, right? So it's central point, and then all the clones, and they already get lost, right? With the clone, if you have a clone, that's already triangle, random names for the remotes. Do you have any facility to assist human beings, to orient in that space?
Yes, I think I can mention one feature there. One inherent problem you have in a decentralized system is, suppose you and I start collaborating on a project, and then we would have a main branch, okay? And then you have a main branch and I have a main branch, but just in the whole distributed system, it's not obvious, like, what is the head of that main branch? Is it yours? Is it mine? Is it some other collaborator that the other person doesn't know? So we have a concept there. We call this canonical references, because it's not only about branches, you can also do tags and basically any reference. And the idea here is that you have some metadata attached to your repository, and then you can list the node IDs or the user IDs that will essentially vote. So you will push something to main, I will push something to main, and if then you can take we do some evaluation there, and you can basically take the common denominator of us, or if I'm ahead of you, then you would agree, okay, let's go with what Lorenz has, because you're just a few commits behind or something, and we do this aggregation for you. So this solves the problem of, for a project, how do you find the current main? And what many people are used to is they go to GitHub, check what the README is of the current state, and they look for the main on the server. But we have no server, so this is one of the first things we have there, and we use these canonical refs. And yeah, and then there are quite a few ideas, but we are not so advanced there. So currently the users can give themselves aliases, so you don't see a random public key there, or random looking public key. But we want to make this extensible in the sense that you can share the names you know of others, and so you can basically introduce people to each other on the network. But we haven't rolled this out yet. And yeah, we know that we should basically never show a hash to a user, but yeah, we're working on this.
This is even next level of weird, you know, from what I was looking for, you know. I wanted just for nodes in the network and kind of orient people, okay, this is the nodes and this is the names associated with them, and oh, I'm connected with that node through this remote, for instance, in Git, right?
Yeah, I mean,
let's say Annex contains information about all of its remotes, right? Which it knows about, UIDs. In your case, you probably have also IDs of the nodes in the network, right?
Yeah.
Which will give some names.
Yeah.
In regular Git, there is no notion of that, right?
Yeah.
There is only your own name for that remote, right? So I was trying to kind of, how could we create a map? In Git Annex, there is some function which creates that graph, right? So in your case, do you have any kind of simple UI to plot the space, you know? Not even to say about, who is the master of that branch, right? Who has the authority kind of.
I mean, you can, of course, you can list the nodes you are connected to. You can list the, like we call this the routing table, which basically maps which node has which repository. You can print this. You can follow nodes that has some implications of which changes you get from them. So there are a few primitives there. Yeah, but it's not, the mapping between a node and a remote is not really one-to-one, because we have quite a few nodes in the network that are more of a relaying function. So we have nodes where really a human uses them on like a daily basis, so it's on their laptop kind of, and usually you would configure Git to have a remote like that is associated with this person that you're collaborating with, but you would normally not have a remote that is associated with like a server that just replicates information, because you're more interested in the person you're collaborating with rather than some machine running somewhere.
So Andreas, I was curious, you when you your problem with performance on a parallel file, so a cluster file system, did you ever identify which part of Git or Git Annex or both was actually what was causing the bad performance there? Like which operations or anything like that?
Yeah, I'm pretty sure it's the data-led status or the Git status underneath. I'm also running more benchmarks on local and distributed file systems, and it looks like the file system cache, it's like maybe it is 50,000 or some number like it, and it's either the file system cache or the so-called D-entry cache, so it's even lower, I would say. Nothing we could solve probably in data-led or even Git directly.
Yeah, that makes sense. So it'd be Git status. Then.
Yeah.
Yeah. Okay. Thanks.
Yeah, I was wondering for Andreas, is it basically ready for us to start using? And then also for the data, for the Slurm finish or whatever that was called, had you considered allowing a feature to have that happen at the end of the job, or does that not seem?
Well, what was the last part, please?
The Slurm finish, do you think that could happen at the end of the job rather than afterward, or does that seem like a bad idea to you?
So basically, last question first. If it would be in the end of the job, then it could happen simultaneously again in multiple jobs. We don't want this. But the thing is, you can basically come back much later, a day later or a week later, and then all the jobs that finished since then, you handle, and then it's fine. And now, what was the first part of the question?
Oh yeah, just is it ready for us to? Is it?
Oh yes, yeah. So it's out there. Actually, I have the fork of the handbook ready, and I will send the merge request so that you can find it maybe next week in the data-led handbook appendix, whatever. And then I would be happy about feedback, also things that may not work yet. And then there's one little quirk, or maybe even a question back to if you have a good idea how to make it available as a pip package, because either you make it dependency to data-led, but then this will clash with data-led installed from the package manager or just separate. For now it's just separate, and then yeah, you install it as just one more data-led plugin, and you should be good to give it a try. Yeah.
Thanks.
Question for Lorenz. You skipped a slide or two on collaborative objects, and that was something I was curious about. Maybe you could sketch in a few sentences how they work.
Yeah, sorry, I didn't time my slides too well. Yeah, so collaborative objects, I guess the idea was mentioned, so you want to collaborate about your code, but you don't necessarily want to like resolve merge conflicts and so on about an issue text or whatever. And then you have ideas like Git bug, for example. Git bug is a tool where you can do bug reports and have that as part of the Git repository. What we are doing is actually very similar. So we just put the issue descriptions and the metadata about patches and so on. We just also put that in Git in namespaces. So we use the Git namespaces feature quite heavily. But we try to generalize a bit from there, because as far as I know with Git bug, you can do issue tracking, but the approach is not very general there, at least to my knowledge. For us, we have more or less like an API, which gives you a tag of operations, and an operation can contain multiple actions. So we have designed this so that there are operations, this is fixed, and now you can come and you can say what are the actions. So and the actions basically mean you start off with an kind of empty object. This is also fixed. But apart from that, you can decide how your actions should look like. If you want to, you can think of this just like a JSON schema of what an action is. And then you have to define how your data structure aggregates these actions. So if, for example, like adding a comment is an action and editing a comment is also an action, now you have to figure out how to resolve what the new comment, or like how the comment should be rendered. But we give you quite a lot of infrastructure to actually achieve this. So all of these corps have this flavor of actions, and then you have a function that traverses a DAG of actions and gives the correct state in the end. And yeah, basically all of Radical, everything that is collaborative, by that we mean multiple users interact on the same kind of object, apart from code. Everything in Radical is built on top of this idea. So our issues and patches, and also the repository identity, which then contains things like the definitions for canonical references, it all uses this system. And yeah, I should also mention that, for example, for CI jobs, we also use collaborative objects, and there are people experimenting with their own versions of issue tracking because they want new fields, new kinds of issue tracking. They don't want to use ours, so they build their own issue corp kind of. Yeah, and we also had people experimenting with a planning board and so on. And yeah, so we can talk about this in more detail, of course, but we are trying to, like, the idea would be to have more of an SDK to plug these things right into Radical.
Cool, thanks a lot.
I have another question. I have another question about Radical. What are your ideas about interoperability with other forges? There's the Fediverse or the ActivityPub Federation protocol. You mentioned AT, but also, I don't know, interoperability with GitHub.
Yeah, so this is a question that rightfully comes up quite often. There are, of course, we would like to support this. And I think it would be rather easy to export into other forges, right? This is nice and all, but it's just one part of the whole story. We really have troubles with importing, and the reason is that all of these actions on collaborative objects, for us, they must be cryptographically signed. And now, you want to import a GitHub issue, right? I totally understand you want to do this, but you would have to write an importer that somehow generates a key and then maps this key to maybe every GitHub user, and then keeps this key custody and waits maybe for the GitHub user to like get the key or something like this. We don't really have a better idea there currently. Maybe someone can propose something that would be really cool. But we really need this on the network, because we cannot rely on some central authority that says, yeah, this user is legit, or it's this ID and so on. We just have to rely on cryptography. There is, for us, no way around it currently, or at least we cannot imagine any different. And this is why syncing back to Radical is super hard for us, because most of these formats, they don't provide any cryptographically secure or signed format that is flexible enough for us to import into Radical. And yeah, we can talk about about this also in detail, but I think really the problem here is that we have just kind of a different standard there, that we need everything to be signed, and we will just not import anything that isn't signed, because it doesn't fit our network really.
How much time do I have? Question to Floris. So you've mentioned that in case of successful hole punching, right? You establish direct connection, and you said, oh, it will be efficient. How much of bandwidth you can actually deliver? Is it like the entire, you could fill the pipe with one connection, or you need to parallelize, or how much overhead would that be to be?
So how much bandwidth is, well, it depends on the size of the pipe, of course. But basically, like, yeah, normally one connection should be able to build this without any issues. We do have, like, it's basically the same overhead as Quick, right, on the protocol level. So like the size overhead is no more than that. Quick has a slightly bigger size overhead than TCP. Quick tends to like shine, at least in the current deployments, tend to shine slightly better in like the last mile kind of protocol. So like inside data centers, you probably wouldn't find it, but like it's going to endpoint devices. But then with hole punching, you mostly are on the endpoint last mile kind of networks. Our own implementation is not the fastest Quick implementation around yet. I mean, we use Quinn as well, which is the Quick stack, and then we do some stuff on top and we extend it, etc. We do track performance, but compared to like basically doing a plain HTTP1 connection to somewhere else, to a stable server, you're going to find a small a penalty, but generally you should not have problem filling the pipe. We have some users who like really push a lot of data through as well.
And just when we tried IPFS, which is kind of comparable to some degree, right? We found that IPFS really slow, and I'm not sure at which level slowness introduced, but that kind of made us showstopper for us. We couldn't use it for our data side.
Yeah, IPFS is, I think, very different. Like IRO is just like the transport protocol, and it is literally just connection, and that part can be like very efficient. As far as I understand, the inefficiencies of IPFS came and I'm going slightly outside of my knowledge here, but like it comes from how they model the trees of all their hashes,
so it's could be
and how you have to like reconstruct the trees, and how you have to re-verify everything. Some of this is like the Blake 3 verifiable streaming is kind of going in that direction, and kind of comes from a similar-ish background. The benefit there is that Blake 3, for example, works on any size file, right? IPFS was built before Blake 3 existed, and they had to do this thing with SHA-1, where they basically, if you have a large file, you have to chunk it, and you have to build your own Merkle tree inside it, and you have to send every chunk as a file, and then you have to reassemble it. That's where a lot of the inefficiencies came from. So if you can use Blake 3 for streaming, that's already something. The thing that I skipped about at the end, where you can do a collection, like a hash sequence, is like for us is a collection of files. It's like, I think IPFS has also discovered this, that their initial model of like, hey, here's a directory tree of files or something, transfer them along, doesn't really scale, and they ended up doing, what they ended up doing a lot more, I understand, this car files, which are basically like, here's a giant file, which is basically kind of archive in a way. And that's also like the idea behind the hash sequence, is like that you basically have a flat sequence of hashes, and that makes access really efficient. And the idea to make that then how you still represent the whole directory or something like that is that in the first blob you put your metadata, and there you say like, okay, the blob at index 53 is this path name or something like that. And that's how you make that part much more efficient if you want to build that kind of system. That's my understanding of why these performance differences made.
Is it ready on IRO? You don't use IRO underneath anyhow, right? You have your different implementation of Gossip, right?
Yeah, we don't use IRO currently. I think one of the main differences here is that we wanted to use Tor to be more censorship resistant and really integrate this very deeply. and Tor currently only runs over TCP, so it's much easier to integrate in like a TCP-based stack. That's why we went with this. But I think in like the development of Radical, we also realized by reinventing quite a lot on the like peer-to-peer side that it would be valuable to look into integration of IRO. So yeah, it's just experimental and just thoughts for now, but we definitely want to look into it, and possible future could be something like we use IRO and then in parallel we don't use really TCP and allow people to connect via TCP, but we use IRO and Tor in parallel, for example. So you could get to choose between IRO and Tor. It's just an idea at this point, but yeah, we are definitely looking in this direction.
Lorenz, I was wondering if you could talk a little bit more about the topology of it. Like, would it be possible to, and maybe I just want to make sure I understand. Could you, for example, have an MDN peer with an MDNS radical instance, and then have that connect to other nodes? And also, I just wanted to say that NNCP, you mentioned that email is a potential remote. NNCP, it has a GET remote and a GET annex remote, and it's a protocol that's just for asynchronous relaying of things, so could be cool. Yeah.
Okay, yeah. Yes, so Radical supports relaying. So if you enable, I'm not sure whether it's enabled by default actually, but you can definitely enable relaying on your node, and this will then have it just really relay these gossip announcements on the network, and that way you could discover a peer locally in your network, and if one of them has a connection to the outside, to some other node, and has enabled relaying, then the others would get this information. And this actually happens a lot on the Radical network, because we are not so strong in hole punching as IRO is. So we don't do any hole punching at all, which effectively means that currently lots of the traffic on Radical is relayed. But the fact that these announcements that are being relayed are again all cryptographically signed is really not that big of an issue. It's an issue if you want to think of topology and you say, no, I reject relays, I want to connect to every node directly. Yes, then it's an issue. We are trying to get there, but we have to make compromises along the way.
I have another question about IRO, also a bit about the relaying part of it. From what I understood, you're basically always building peer-to-peer connections between two nodes directly or via a relay. Is there any idea about using routing and having multi-hop connections? There are some quite nice routing protocols, like Babel, for example, to do that.
Basically, we consider this a thing on top. Like, you can build, the IRO itself is not going to do that. Like the base library is not going to do that. It would be one of the protocols on top, like the gossip protocol or whatever. We haven't done that yet. I've heard the question before of some kind of overlay network of how do I build a routable network out of these connected peers? I imagine at some point this will happen. Someone will do it, maybe us, maybe someone else. But for now, the focus is still on do the basic thing really, really well.
Yeah, thank you.
Actually, on the topic of parallel file systems, I think anybody who's had enough contact with them has gotten to experience the joys and limitations of them. For us, what what we've done is to try to break apart the layers of storage a bit and provide local storage on the compute nodes for kind of the exact same scenario that you're in, is that if you're going to have these ephemeral checkouts for each job, then they don't necessarily need to be on a file system that is shared across the entire cluster, because you only need it on the local machine that happens to be executing it. And is this and at that point, it basically puts our parallel file system into a staging area for inspection after the results of everything. And is this something that you've experimented with or looked into? Yeah.
Good idea for the next step. Unfortunately, there is another typical HPC thing which will prevent it. So you could say, my job is running on compute node 1211, but you only find out when the job starts. So then you could go there and get clone your repository there in a local file system. Then you would prevent those issues. But again, this would be some sequential step at the beginning of the job. And if 10,000 other CPU cores are idling during this, someone from the compute center will look for your phone number and give you a call.
Yeah.
Yeah.
Yeah, it makes sense. I know that at least HT Condor has the concept of staging data beforehand. I don't know if Slurm has that. And if you're doing initial, the advantage of these kind of clones is that it's going to keep your cache really, really hot. So yes, you do have the sequential step right at the beginning, but they're all performing the exact same thing. And so you're just in a position where you can cache that a bit more aggressively.
Yeah.
Might be worth looking. It doesn't solve everything everywhere, but.
So, in principle, at least, some of the steps, this is also what Adina et al. Did for their work. And in the end, this is down to conventions in the HPC field, which sacrifice a lot of things, including some security for efficiency and performance. And this balance you need to get right, or if you really want the really big jobs, a lot of performance, you make those compromises as well for your big computations.
Okay.
Yeah.
Cool. Thank you.
Yeah, maybe a question is somewhat related to that. You referred to the fairly big workflow and pointed out inefficiencies. And one of the aims for that workflow was that it should enable people who have no access to the original environment, so no HPC account, to reproduce some of the steps, right? So it was about reproducible science, right? And if you can't recompute all 100,000 jobs, you can sample 23 and do that on your laptop, right? To build confidence that what you got is what was described. And I'm wondering whether you had to sacrifice that for efficiency.
So to some extent, so it's okay, or it's possible, of course, to reproduce individual jobs of yours. You don't have to reproduce all of them. And if you say one of those HPC jobs, which runs for 10 minutes on a quite big cluster, or say 200 CPU cores, you could reproduce locally with some additions, but principle it's doable to reproduce it locally on your laptop when you are okay with waiting many hours, and this would be fine, assuming the memory is enough, of course. As soon as you are stepping something like thousands, 10,000s of CPU cores, this will not work anymore. But then this is a principal thing. Of course, you cannot do the same thing than do really big iron with your laptop. But still, if you have adequate resources, you can reproduce it. But making the biggest job that you imagine on the biggest cluster reproducible on a really old laptop, of course, is going to break somewhere.
Okay, thanks.
I have a bit of a basic question to Lorenz about radical. So for me, for a while, the thing that was hard to imagine is what happens when I push something to the radical network. So you showed us a picture where there was much gossip and not as much pull actions. So if I push to radical, I guess I have to trust that somebody will take that up. So who would that somebody be in practice? And conversely, if I decide to run a radical node on my server, what will it be fetching? Will it be fetching everything, or do I get to say what it stores and what it doesn't?
Right, so this happens mostly on a per repository basis. So yes, you think about connections between nodes, but then immediately you think about a repository, and you would usually, you push in the context of a repository, and then your node announces, if it's a public repository, to basically anyone, that the references of your namespace in this repository changed. And then the other nodes can decide what they want to do. And if the other nodes are interested in that repository because someone configured them to be interested in that repository, they will come to your node and fetch. And your node will say, okay, I've just changed this and that file. And then they will be updated. And this happens relatively quickly. So if I push to hardwood, it takes, I don't know, like less than 5 seconds for 80 nodes in the world to be in sync with me. It takes less than 1 second to be nodes that are close to me geographically to become in sync. But now the question is, okay, how do these nodes decide which repositories they want to be updated on? I think this was like your second question. And yes, this is configurable. So most people configure their nodes to only replicate a specific hand-selected set of repositories. This is quite common, and I also do this for my node. I select the repositories that I'm interested in as a user or that I'm collaborating with. And also for us, this is some way to kind of endorse a project, which is a bit fun because on GitHub you might star a project to say, yeah, this is cool. But what you can do on Radical actually is you can say, make a copy and make this available to anyone who is connected to you, and basically also share like your bandwidth, which is, I think, like a much nicer way to endorse a project. Yeah, so we have this idea of seeding a repository, and we say, yeah, don't just start a repository, just start seeding it. And of course, you are in full control of your node. You can at any time decide to stop seeding something, and then you can also delete the repository from your local disk. And then there are people that are willing to basically seed any repository they find. And we have a legal disclaimer also on our website about this, because depending on your jurisdiction, you should be careful if you do this. There are currently, I think, on the order of 200 nodes on the network that we know of. There are also some nodes that we likely don't know of. And there are more than 5,000 repositories on the network currently. Many of these, to be perfectly honest with you, are people trying it out and making 2 commits and pushing their hello world and something, so really it's boring. Then there are quite a few people that actually use it for development. Yeah, so currently you can seed the whole network with like 50 gigabytes or something. It's not that big. It will of course get bigger. And as it gets bigger, we will improve the features of handling this. We are thinking about sharing like the list of repositories that you're seeding with others, and yeah, improving the whole story around that. Yeah, so I guess to put it short, you can choose which repositories you want to seed. They will be replicated, and if you push, the changes to these repositories are immediately announced to every node that is allowed to see them.
since I confessed yesterday, I'm a data herder, right? So I have those 8,000 repositories with Git Annex and Datelet, and you said it's okay. Should I contribute to the network, all those 8,000, or it's not useful? Will it survive?
I mean, you're very welcome to. We had a few occasions where people basically started dumping their all of their Git repos on our network, and yes, this is a bit of stress on the network because there's a bit of announcing going on, because the nodes that decide to replicate the whole network, they will all be announcing, "Yay, I am now seeding all of these repos." This takes a while. It's not super efficient, but it's not a problem. Like, everything remains stable. So you're very welcome to put your repositories in Radical.
Are there any ideas about how to provide extra metadata? Because Git Annex, let's say repositories, I could have some content in my clone, right? And I have information which other clones have that data, right? So how could we benefit from distributed nature here even more for Git Annex?
I'm not sure about Git Annex, but we have a concept in Radical that is the repository identity, which is a file in a canonical location in a collaborative object, and it's tied to a repository. And it's a JSON file, and we use this to add metadata about the repository, and this is extensible. So we call this payloads. So there are multiple payloads. They're pretty boring ones that just declare the name of the repository, and there are more interesting ones that declare the canonical references. And this is the way we intend to extend the system over time. And now, if you say that there's some information you want to communicate about a repository, then this would be the place to put it. So you could design your own payload. Would be nice to tell us that, you know, there's this new payload with this schema that you're adding, and then, yeah, this would be like my first, if I understand correctly what you're saying, this is where I would suggest to put that info.
Thank you.
All right, well, on the topic of Git Annex, and you said there's no real plans to add Git Annex support to Radical, or am I hearing something more positive and open on that? Because, yeah.
No, I would be very open to hear what you would require. Because my naive understanding still is that Git Annex just uses Git, and you can replicate Git repositories and should all be fine. So I guess I'm failing to understand what you would like, which interop you would want with Radical, if that would be a thing.
Yeah, I think there are people here who are far more qualified than I to explain what's going on underneath all of it. But for me, there's Git, and then there's the Git Annex objects, and so I maintain a computational cluster. And from my perspective, what would be really cool for me, like the biggest problem for me is the thundering herd. Like if just a couple jobs are going and getting a random data set, I don't care. But when 50,000 jobs show up for this and Adina decides to make my day more interesting, then I tend to take notice. And so in my absolute dream world, clients, like jobs go out and they could use something like Radical and they could clone. But wait, there's 50,000 of these. Maybe not all of them are going at the same time, but I've got a bunch of clients that have popped up onto this very fast local network. And they can all start giving each other the information that they need. And then they start doing the equivalent of like Git Annex Git. And of course I can use things like BitTorrent or something like that, and I can set up local seeding, but it'd be really cool if the Radical client could do this natively. And then every job that wants something helps make that network stronger. And then I don't have this problem with parallel file systems. I don't have this problem with trying to size my web server to be able to handle the worst case scenario. Instead, the more popular a particular job set becomes, the more robust the network becomes. And then, as it becomes less popular, it tears itself down. And then I have a really resilient, really capable solution. But that's not something I can build. That's something I can try to convince you to build for me and make me look good. So that's kind of the dream.
I like your dream. But a basic feature, if Andreas could correct me, for Git Annex is to be able to request UID from the other remote. so another node, you full-featured Git-annex thing from which I could request the data. So that's pretty much, and it goes through pulpating.gitconfig file on that remote. So do you, let's say, channel anyhow Git configuration from the remote?
Yeah, we don't do such things for now. Yeah, we can talk about this.
Yeah, but you have node, you said manifest, right? So that's where
Yeah.
such information could be posted, right? So that's it.
Sounds like a payload can support that.
Maybe. Yeah, let's talk about it.
So I know a little bit about Radical and a little bit about Git-annex. And the question you had is a really interesting research problem. We'll get back to you in 5 years. Please help. Please help.
All right, and I guess on that note, we can thank our speakers because the coffee break is approaching fast. So